And welcome back, guys. Well, we are back to do more fluid mechanics. And the last video we were talking about how to name the stresses. Hopefully that didn't bore you too much, because it's a very tedious, long, pretty uninteresting way of defining vectors and everything. Now we actually get to a little more about how these stresses actually contribute to our force balance, or the Navier Stokes equation, however you want to call them. So yeah, we are looking at the stress component that it's going to affect this body. Okay, so let's look at the stresses again. Let's look at our little box here, our control volume, this little box. So let's do a x direction. So we want to do a x direction. Let's make it black in color. X direction, momentum balance. Okay, so x direction, momentum balance. So what are we going to do with x direction, momentum balance? We need to find out all the stresses which are acting in this x direction. Alright, so we have this cube. Okay, we have this cube, and then we'll need to find the forces acting on each face. So let's consider, again, this face right in front of us. So I'm going to color this one yellow. So, okay, this is, okay, the y coordinate here is y. We just call this y. Alright. And previously we named it x plus delta x. X, we call that the same thing. So this is y, this is delta y, so this is y plus delta y. So let's write y plus delta y. The same thing for the rest of the things. So this is x here, and this is x plus delta x at this point, and of course here is z, and this z coordinate is z plus delta z. Alright, so I'm going to just erase all this, just so you know what's it's clearer. So let's consider this front face. So this front face, this is at y. The y coordinate is y. And then we'll have another face, y plus delta y. So I call this the y face. Then the y plus delta y face is at the back of the cube, over here. Okay, is at the back face. I'm not drawing it very well, but that's the idea. You want it at the back. So there'll be two cubes, two faces. Alright. Now, okay, so this is the y face, this is the y plus delta y face. And of course, we have a coordinate system that looks like this. So this is the x direction, and this is the z direction. And of course, we have our line, our z equals to x line, or x equals to z, or z equals to x, however you want to call it. Alright, so we draw that line again, like this. And we know the shear stress is pointing towards this line. If you're on this line, you're pointing towards the blue line, you're positive shear stress. Okay, so let's see what acts in the x direction. So let's first draw all the stresses relevant. 1. So let's have the normal stresses. We put it I like to use a green color for it. 2, 3, 4. And I'll move this because it's pretty much the same. Alright, so what is this stress? What direction is this? this is a normal stress going in the z direction, and it's acting on the plane z. So this is, as we learned in the last video, sigma in the z direction. So it's acting on the plane perpendicular to z and in the z direction. And this is also sigma zz. But these two sigma zz's are slightly different. One is evaluated at z, and this is evaluated at z plus delta z. Alright, same thing here. Look at this. What is this stress? Well, it's acting on the plane perpendicular to the y, and it's in the y direction, so this is sigma yy at, oh no, this is not sigma yy, this is sigma xx at x plus delta x, and this is sigma xx at x. Okay, so our normal stresses are done. Okay, now let's take a look at our shear stresses. Positive is this way. I'm going to use red for shear stress. So downwards is positive here, and then we'll have upwards and leftwards. So let's name our stresses again. So what plane is this acting on? This is perpendicular to the z plane, so we'll call it tau because it's a shear stress. It's acting on the plane perpendicular to the z direction. And what direction is it going? X. And where is it evaluated at? It's evaluated at z plus delta z. Alright. And what is this? It's the same thing. Well, it's acting on the plane perpendicular to the z direction, and it is at it's going in the x direction, and it's evaluated at z. Okay, what is this one here? This left one, this is again, what plane is it perpendicular to? It's perpendicular to the x direction, x. And what direction is it going in? It's going in the z direction. Where is it evaluated? It's evaluated at x, because this left side is x, this left side is x plus delta x. So again, let's look at this fourth arrow here on the right. This fourth arrow here on the right, it's a shear stress, so we'll name it tau. And what is it, which plane is it acting on? It's acting on the plane perpendicular to the x direction, and it's pointing in the z direction. And it's going to be evaluated at x plus delta x. Now, which are the forces that are acting in, in the x direction? Let's circle them out. 1, 2, 3, and 4. Right? So 1, 2, 3, and 4. Okay? These are the stresses acting this way. Now, I want you to note, as said before, there is yet another stress that's acting along this way in the y direction. Okay? So there's actually a y plane in there, because this is a 3D problem. Now you're wondering how we're going to determine which is the positive direction. Don't worry, we'll come to that somewhat later. So for now, we'll just keep it simple. in a 2D way. Now, let's consider the y plus delta y. Okay. At the y plus delta y, oopsie, y plus delta y. And we find that the same stresses are acting on this. Because, you see, when we are talking about these planes, this flat line here is actually this plane here. Can you see? Okay, let me draw box. One at the back, one at the front, one at the front and one at the back. So let me color this blue. Oh, this is a much nicer looking box. Why didn't I think of that earlier? Oh well, so much for that. I should use this next time. Anyway, so when we talk about this flat line here, this is actually this plane. When we talk about this flat line here, is actually this plane. The top one is this plane, and the bottom one is this plane. Okay. So when we have looked at this square thingy, we have considered these four planes already, and we have talked about the forces acting in the z and the x direction. Of course, there's a force acting this way in the y direction as well. There could be forces in this way, but we don't need to worry about that because this is a x direction momentum balance. So we have already considered forces acting in the x direction for this plane, this plane, this plane, and this plane. So that's 1, 2, 3, and 4. So that's 4 out of the 6 planes already. Okay, so I will, I will just copy this diagram. Yep, so we look at the y plus delta y, but you don't need to worry. It's actually the same thing because we are talking about the box at the back. The box at the back, that's the y plus delta y plane, and it's going to have exactly the same forces because we are talking about this flat plane, the bottom, the left side, the top side, the right side, and the bottom side. Alright, they're the same plane. When we're talking about this flat line, we're actually talking about this plane. Okay, so let's put this down. Okay. Let's put that dimensional analysis somewhere else. Put a few pages down. Okay, let's go up. Function, page up. Alright. Alright, so we have this already. So we have singled out 4 forces, or 4 planes, and the x direction forces on each plane. So what are they? Tau zx at z plus delta z. That's 1. Number 2, tau zx at z. Number 3, sigma xx at x. Number 4, sigma xx at x plus delta x. Now, each of these stresses represents a force acting on one of these planes. So we need 2 more since there are 6 planes. Alright. So to do that, it's very simple. We consider the xy plane. We just consider this plane. Let's draw it here. We consider this plane or this plane. So when we consider this plane, alright, so x is this direction, y is this direction, z is this direction. So the bottom side, from here to here, this is the y direction. Here to here, this is the z direction. So we're talking about the YZ plane. So here is y, here is z. Now we're going to repeat the same thing here. Okay, we're going to shift this down here. Let's make more space for ourselves. Okay, now let's again do the normal forces. I'm going to label these green arrows. 1, 2, 3, and 4. Okay, and then we'll have our y equals to z line, or z equals to y line. Now I'm going to put that at the red color, and then we're going to draw a line like this, and of course it'll be in this direction. Okay, then we'll have our positive shear stress directions. So again, pointing towards the red line. 1, 2, 3, 4. Okay, let's start naming these stresses. Now, where is this? Let's look at this one, the bottommost one. The bottommost one, what is it perpendicular to? This is perpendicular to the z-plane and it's acting in the z direction. So this is sigma zz evaluated at where? Z. The top plane, sigma, it's acting on the plane going in the z direction, zz, and where is it evaluated at? It's evaluated at z plus delta z. Okay. Let's see whether we copied that over. And then what's the left one? This is also a sigma because it's a normal stress. Where is it acting? It's acting on the plane perpendicular to the y direction. So this is evaluated at y, because this is y plus delta y. So you can't get the pattern, I hope. Sigma yy. Oops. Let's try again. Sigma yy y plus delta y. So I'm trying to move this over, maybe here. Okay, let's do this. Let's shift this guy over here, and I'll bring this guy up. Problem solved. Alright. Now, you'll see that we already have some commonalities. Alright? It's very, if you're pretty observant, you see that this sigma here is already described here. Can you see? We've already seen sigma zz before. Okay, so we're actually talking about the same stresses here. Same stresses, so we don't have to think of them again. Well, we can eliminate the duplicates later. Let's just finish naming our stresses first. Okay, what is this one? So this is acting on a plane perpendicular to the y direction, and it's a shear stress, so it's tau y z, because it's going in the z direction. Where is this evaluated at? This is evaluated at y plus delta y. And this, same thing, tau, again y plane, perpendicular to y direction. I'm going to speed it up because it's quite repetitive. So it's evaluated at y, it's in the y plane perpendicular to the y direction, going in Z, and it's evaluated at Y. This one is a shear stress. Which plane is it? It's perpendicular to Z, and it's going in the X direction. Tau Zx. Where is it evaluated at? Z. So the other one will be tau Zx Z plus dz, or delta Z. Okay, let's see which ones are the common ones. Now, sigma zz is common, tau xz is common, so let's just call this what? Common and common. So this is nothing new. Okay, these two are nothing new. Alright, so what is this? What are we left with? We're left with this, guys. These are going in the Y direction, which I'm not that much interested in. And these guys are going in the Z direction. Again, we are not much interested in yet, but this will become very useful for our Y and Z momentum balances. So let's just copy this down first. These are good diagrams. So I'm gonna stop the video here. I'm gonna continue the next one. Lest this video, if not, this video will be very, very, very long. So see you in the next video. Bye bye.